All right, everyone. I'm here with Brian Granger. Brian is a senior principal technologist with Amazon Web Services. Brian, welcome to the TWiML AI podcast.
Hi, Sam. Thanks so much for having me.
Looking forward to jumping into our discussion. You are a co founder of Project Jupyter, and that is, of course, a topic that we will be digging into in this conversation. But to get us started, I'd love to have you share a bit about your background and how you came to work in machine learning, and we'll make our way to the founding of Jupyter as well.
Yeah, definitely can walk through that. As you mentioned, I'm a senior principal technologist at AWS, and I've been here at AWS for 3 years, coming up in February. Before that, for the sort of decade and a half prior, I was a physics professor, most recently at Cal Poly San Luis Obispo, and then before that at Santa Clara University. Uh, Even though as a physics professor, most of the time at the university, I built open source tools for data science, machine learning, and scientific computing. And so I have a background in theoretical physics, but that's sort of evolved over time through software engineering, building tools, and more recently, I spent a lot of time on UX design and research.
Nice, nice. And so, how did Jupyter come to be?
Yeah, it's a fun story. So if you rewind back to the early 2000s, Linux was really taking off. Python had been around for a few years, but it became visible in the scientific computing community. And a classmate of mine at CU Boulder in grad school, Fernando Perez, had started to use Python in his research. And he's really the one that introduced me to Python. Both he and I, uh, during our physics education, used Mathematica a lot. And even
Mm,
though we were uh, doing computational physics in other languages, we weren't necessarily using Mathematica. We had always missed the notebook interface that Mathematica had. And in 2001, Fernando released IPython, which is an improved and enhanced command line REPL for Python that had some of the ideas from Mathematica in it, although it didn't have the full notebook interface. And so in those early years, I started to play with Python a bit. Fernando was working on IPython. And then in 2004, he visited me in the Bay Area. I was a young professor at Santa Clara University. And while he was there, we spent a lot of time talking about computing, what we were doing in our research, how we were using these tools. And it was really then where the vision of creating a web-based notebook for Python came into focus. And there was a couple different factors in that. One, it was something that we wanted to use in our own research. We have found over the years that the sort of interactive computing in a notebook based interface where you also have a document was extremely useful, and we just wanted it to exist. The other dimension was that by 2004, uh, rich web applications were starting to appear. And so it started to make a lot of sense to us at that time that if we were going to build something like this, it should be entirely web based. Now, that was 2004. It took us until 2011 to release the first version of the IPython notebook. And some of it was us learning about this space. We were theoretical computational physicists, not web developers. We wrote a lot of code as physicists, but very of a very different nature than this, obviously. And the other is that modern web technologies, even in 2011, were relatively primitive. And from 2004 to 2011, we were really uh, waiting for modern web technology to catch up to what we needed. And even in 2011, state of the art at the time was jQuery and Bootstrap. WebSockets had just been turned on in all the browsers. And we were using all the latest stuff in 2011, which now seems rather primitive compared to what we have today.
when we think about Jupyter or talk about Jupyter today, it's often in the context of ideas like literate programming, were you thinking about it from the perspective of literate programming and some of the theoretical foundations of why a tool like this makes sense, or was it kind of strictly a scratching your own itch and trying to bring to Python this interface that you loved in Mathematica?
The connection to traditional literate programming came much, much later. And I think we in and so the phrase that we use, uh, there's sort of two phrases that we use. One would be uh, literate computing rather than programming,
Okay.
and the other
What's
is
that distinction for you?
so in the traditional literate programming paradigm, there's nothing interactive about it. Right? There's no You're not actually as a human interacting with the live code as you would in a REPL. You just write a source code file and then you use the literate programming tool to compile that to the actual source code file that can run. There's
Hmm.
nothing interactive about it. And in scientific computing and data science and machine learning, that interactive experience of writing and running a bit of code, seeing what the output is, and having a stateful process that holds the state of the program in memory that you can then write more code against. And so that's where we've always thought of it as literate computing,
Okay.
or interactive computing. Another phrase that we talk about a lot is the idea of a computational narrative. And again, the
Mm.
focus there is on a narrative that's contained in a document, but it's not about mere programming, as in typing code. It's about actual computing. It's about writing code and running it, seeing the result of that, and using that to think about data in the case of machine learning.
So I think you got us through 2011, 2012, all these new web tools kind of catching up to what you needed. Around that time, we also saw an explosion in machine learning, deep learning interests. How did that shift what was happening with the Jupyter project?
Yeah, so in the early years, when we thought about what would success look like for us in building this web-based notebook for Python, I think our sort of market, if you want to phrase it that way, would have been academic researchers who are doing scientific computing. That's the universe we were in at the time. Those were all the people we were talking to. Um, and every time, all through the early 2000s, whenever we talked to people in industry, they looked at interactive computing with a bit of a sort of, oh, that's nice, but we never need to do that. I think Fernando even had a conversation with Guido van Rossum, who is the creator of Python. And when Fernando described how we use Python interactively, Guido said, "Wow, I always thought of the Python REPL as being a bit of a toy that no one would actually use for real work. It's amazing to see how, in the scientific computing context, you live in these interactive shells." Um, and so we had always thought that sort of the commercial adoption of these tools would be very slow at best. Now, it sort of came in from the side that around the same time, uh, commercial entities discovered the power of data through data science and machine learning in a way that they hadn't before. And so they ended up needing these same tools for interactive computing, and they quickly discovered Jupyter as one of the tools that they could use for this. But it took, I mean, I remember in the early, so starting in 2011, going up to maybe 2015, was an amazing time for us in that it felt like every month a new major organization discovered interactive computing and Jupyter and Python. And I would say by the time we got to 2015, 2016, uh, it was a lot of people, a lot of companies were using these tools as well. But it was a transition and growth that we had not seen coming and definitely hadn't planned on. And it created a lot of challenges for Jupyter as a project.
Hmm. Hmm. Was it obvious that you should embrace these new use cases and new user communities, or was there a bit of tension between kind of staying the course and building the thing that your scientific computing users needed? versus things that machine learning users might need it, to the extent that those have are divergent in any way.
Yeah. So I don't want to imply that there's never been tension there. I think the I don't want to speak for all Jupyter contributors, but I can try to summarize some of the sentiments in the community. Um, we even today, so today Jupyter is used by many large corporations, and many contributors to Jupyter today work at those large corporations. Back in 2011, it was close to 100% academics working on Project Jupyter. And even today, I think the core Jupyter team deeply values the role of Jupyter in research and education. We recognize it's important in the commercial space. We definitely want to address those usage cases. But I think broadly speaking, the Jupyter community holds the research and educational usages with sort of special importance. And so there has been some tension there. Now, the other question you brought up is the potential for divergence between the needs of the academic users and commercial users. I think to first order, the experience we've had is that there's no substantial difference in the needs of those communities. It's even to the point where it's a little humorous in the sense that even still to this day, we regularly talk to organizations that will tell us how they're using Jupyter and start out by saying, the way we're using Jupyter is really weird and special and probably like unlike anything you've ever heard. And then they'll tell us a story that we've heard hundreds of times about they're doing all the same things that everyone on the planet's doing with Jupyter. That's not to say that they're not differences. For example, in the academic context, the requirements of teaching are really unique. And so when you're teaching a large class in a university with notebooks, being able to manage homework, assign homework that involves notebooks, grade the homework involving notebooks. And so we've built
Mhm.
special capabilities for things like that. But at the core, I would say most of the functionality is common across all Jupyter users.
Got it. Got it. Got it. And so you're now at AWS and you continue to work on Jupyter. How did that come to be?
Yeah, so as I mentioned, somewhere in maybe 2000, by 2015, 2016, commercial and enterprise usages of Jupyter had really taken off. And what that meant is that the Jupyter developers were talking to a lot of users that were no longer individual users, but were people maintaining and operating large scale Jupyter deployments in their enterprise. And the pain points and struggles that they were having sometimes were related to Jupyter and would be either bugs or feature requests or enhancements that we could make on the Jupyter side. In other cases, the challenges that they were running into really were not a Jupyter problem or challenge. It was more of a uh, deploying and maintaining cloud infrastructure type of problems. A great example of that would be entities that have some manner of private or sensitive data and need to deploy Jupyter to meet a certain compliance regime, such as HIPAA. And that's not really a problem that Jupyter as an open source project is going to solve in an end-to-end way. Jupyter may offer building blocks that can be used to assemble such a system. And and so that was one of for me personally, starting to talk to these enterprise users and realize, okay, there's a huge need here. We're probably not going to be the Jupyter open source community is not going to fully solve these needs. I'd love to start to work in an organization that's really good at all those enterprise cloud computing challenges. That was one dimension. The other dimension was us thinking about the long term sustainability. Um, the As a result of the adoption in the enterprise commercial space, the user base of Jupyter grew far faster than the size of the development team of Jupyter. I think the Jupyter user base has been growing exponentially with a doubling period of I don't remember. It's about a year since I think 2015. The Jupyter contributor uh, population has not grown exponentially. We've grown a lot, and so we've really faced a resourcing issue where we just, as an open source project, have not been able to keep up. And
I love, by the way, that you said it was growing exponentially and actually meant exponentially.
oh no, no, I can no, I can show you the plot where I'm getting this from. Is we have a a chart that we periodically gather, and that is the number of public notebooks on GitHub. There's a number of different ways we measure how big the Jupyter user base is, um, but you can see we have a chart in this repository in a notebook that shows the growth of notebooks, public notebooks on GitHub, and it's been growing exponentially since I think somewhere
Mhm,
around 2015. Um, so yeah, and so part of this was the Jupyter governance model has always been multi-stakeholder. We've designed it, and some of this came out of our own needs. Fernando was at Berkeley, I was at Cal Poly, so almost by definition, there's multiple stakeholders and organizations involved. As additional academic contributors came on board, and then eventually contributors from companies came on board, we embraced that multi-stakeholder nature. And I think from this perspective, my moving to Amazon was an opportunity to bring a new stakeholder into the mix of improving and making Jupyter a sustainable and growing open source project.
mhm. And the governance model is it's Jupyter's part of the NumFocus Foundation. Is that correct?
Yeah, NumFocus is a 501c3 nonprofit that's the umbrella organization for a number of open source projects in this space. That would include NumPy, SciPy, uh, Pandas, SymPy, Jupyter, and dozens of others. I know I'm forgetting. There's
There are
there's
quite
more
a
than I
few.
can possibly name. So Jupyter is one of those. Uh, Jupyter in NumFocus, each of those open source projects has its own governance model. It's
Oh,
not
okay.
like the Apache Foundation where there's a single governance model that everyone adopts under the foundation.
Mm,
Um, and we actually, in the Jupyter side, have been refactoring and designing a new governance model over the last 2 years to address the scope and scale of Jupyter. And we've been sort of rolling that out incrementally over the last year, and have, still doing work to finish that up. But the core idea is that it is multi-stakeholder, and we're trying to build checks and balances to include cooperation and a vibrant community among all these stakeholders.
so you've talked about the kind of what's in it for Jupyter in finding kind of an enterprise cloud home, if you will. What's in it for AWS, and how and why does AWS invest in Jupyter?
Yeah, this is a great question. So the story of Jupyter at AWS actually began before I joined, and so as AWS was diving into machine learning and data science, the question came up of what do we do? Our customers are asking us about notebook platforms. What are we going to offer for that? And a decision was made before I joined to embrace Jupyter. And it really came from feedback from customers. Uh, the leadership team and in the org that I'm in, the AI ML org at AWS, we spent a lot of time talking to customers, understanding what they're doing, what their pain points are, what existing open source technologies they're using. And uh, like I said, even before I joined, we heard the resounding chorus that people were using Jupyter and they needed help deploying Jupyter in a secure, cost-effective way, and that they wanted actual Jupyter. They didn't want a notebook like solution. They wanted real Jupyter. This is also something that made it possible for me to join AWS, and very attractive to join AWS. I didn't need to start at the sort of very beginning and argue and make a case at AWS for why Jupyter. Why should we ship Jupyter versus build our own notebook? That was already done and settled. And so since I've joined AWS, it's more been a question of how do we at AWS make sure that Jupyter continues to be the best notebook platform, and a vibrant and growing open source community.
And at AWS, across different projects, there are different approaches to engaging with open source communities. Um, it sounds like the the way that AWS is engaging with Jupyter in terms of, or rather, the way that AWS is incorporating Jupyter into its projects is to try to stick close to kind of the core Jupyter as opposed to forking it off into something else.
Absolutely. Yep. Now, one of the things that, and this gets back to a technical and architectural principle that Jupyter has used since its founding, and that is Jupyter at the end of the day builds Lego pieces for notebook platforms or for interactive computing platforms. And the idea is that enterprises and organizations can take those building blocks and assemble them in different ways. And at AWS, that's exactly what we're doing. We're taking the open source building blocks and assembling them in a particular way to serve the needs of our customers. And so we may build, and we do in fact build additional things on top of it using the various extensibility APIs that Jupyter has. So, for example, our machine learning IDE at AWS is SageMaker Studio. It's based on Jupyter Lab, but then on top of that, in the SageMaker team, we've written a bunch of Jupyter Lab extensions that add machine learning specific capabilities to make it an end-to-end solution for machine learning. And those extensions that we're building wouldn't make sense to be in Jupyter from an open source perspective. They are a lot of them are specific to AWS. Jupyter as an open source project works really hard to have a essentially vendor neutral perspective. So if you look across Jupyter's different code bases, you're not going to find a lot of code that's specifically tuned to a particular cloud platform or deployment context. Um, and so in at Amazon, we're extending Jupyter. We're building additional domain specific capabilities on top of that. But anytime we're looking at either bugs or enhancements to the core of Jupyter itself, our approach is to work with the Jupyter open source community and contribute back those changes. And so we have a dedicated team of engineers. It's a small team, but they're 100% focused on upstream contributions to Jupyter with the goal of making sure that Jupyter continues to be the best notebook platform out there. And that is, and it's again, not just about the software, but it's also about the community, the open source community. And so we're participating in that open source community in a way that we hope makes it sustainable and growing, inclusive and diverse.
Zooming out a bit, I'm curious how you think about the broader ML tooling space, and Jupyter is just one piece of what a data scientist or machine learning engineer might interact with to get a an idea for a model from that idea into production. Yeah, how do you think about the that broader space?
Yeah, and so for this, I'll start with the landscape of products we have at AWS for machine learning under the SageMaker umbrella. And what we're seeing from customers is that there's a bunch of different tools and capabilities they need to go all the way from the beginning of the machine learning workflow, where they're preparing data, importing data, all the way to building models and then deploying them and then using them to make predictions, whether it's in a product through an API, or make predictions that are more consumed by humans in something like a dashboard. And we've been building the tools at AWS and SageMaker for the different parts of that machine learning workflow in close collaboration with customers. As a, one of the AWS leadership principles is customer obsession, which means that we spend a lot of time talking to customers and understanding what they're doing, what their needs are. And so all the different things we're building in SageMaker are a response to what our customers need. Now, with that said, I think that the challenge that's emerging more broadly is one of complexity. That if you look at all the tools a large organization would have to string together to cover and span the complete end to end machine learning workflow, to have those tools address the different personas that are participating in machine learning, whether it's data engineers, data scientists, ML ops engineers, etc. There's just incredible complexity. And the complexity is along a number of different dimensions. There's fundamental complexity in the data uh, people are working with. There's complexity in the algorithms they're working with. There's workflow complexity. And then there's the reality that this this nice picture that we have about the machine learning workflow that starts from importing data to exploratory data analysis to data preparation to model training to model evaluation, deployment, it's never linear in practice, right? Someone starts working with a data set, and the initial questions they're going to be asking are very basic, such as what's even in this data? What might we predict? What business questions might we predict with this data? And they may get to the end of that initial pass and discover we're not even close to being ready to building a model that we can deploy and make predictions against. We have to go back to the beginning, clean up the data, gather more data, join it with other data that we don't have available. And then they're going to come back and do that again. And maybe this time they get a little further and start to feel like, oh, okay, we may be able to predict this. Let's dive in and see how far we can push it in terms of the quality of the model we can build. Um, and then after that, they may have to look at questions around bias and explainability and understand, well, okay, we have a model that's performing well, but can we use it responsibly and ethically? And they may have to do another cycle through all of this. And this iterative nature and then the complexity of the overall workflow, I think, is something that we at AWS and everyone across this entire industry is just starting to grapple with. I'm hoping that 10 years from now, we look back on this stage and say, wow, we've made incredible progress, uh, really on the side of UX design and human computer interaction, that our systems will evolve to the point where they still have these capabilities, but allow human workers who are using the tools to have a much simpler experience. And I think that's the main challenge we have right now.
Yeah, digging into the user experience and HCI aspects of this, I know that's something that you are very passionate about and spend a lot of time researching. Uh, what you know, what have we learned, or what have you learned and have applied into Jupyter, or what's kind of changed the way you think about Jupyter, or what from those spaces do you think will kind of impact the way that you build these tools and guide these tools in the future?
Yeah, there's a number of different dimensions here. Um, I'll maybe pick two of them to talk about briefly. One is that in organizations that are doing machine learning and building machine learning tools, you're pretty much guaranteed that by definition they're engineering heavy. Right? If you look at these organizations, you're not going to find a lot of UX designers that just naturally work into the process. So that's the first challenge, is sort of the weight of engineering required to build these systems and use these systems is massive. And even in organizations like SageMaker in the AWS AI ML org, we have been very deliberate to build out UX design teams. And yet, if you look across our organization, we're still very engineering heavy because the problem requires it to be so. And so, just the weight and momentum of engineering presents a lot of challenges to prioritizing the human experience of these tools. And so, a lot of what I'm working on right now at AWS is building mechanisms to help us include the consideration of the human experience in this. And it's a lot of fun to be diving into that, but certainly very challenging. And I think the key is that at least at AWS, it's rather new to build tools where the human experience is so primary and important. And it's a growth area for us, and something that we're spending a lot of time and energy and investment on to improve in this space. The other dimension of this is, I think that there's very few situations where we, as humans, have tried to design tools that are this technically complex. And what I mean, I'll use an analogy here. I'm a car nerd in addition to being a data nerd. And if you think about how people approach car design, if you're designing a hatchback for a mass produced market, you can have uh, UX designers come in and look at the human needs. And those UX designers will not need to know much about the technical implementation of that car, right? They're not going to need to know about that. They can work with engineers who can handle all that, and it will work wonderfully. If, on the other hand, your job is to design a Formula One racing car, anyone involved in that product, I mean, if you want to think of it as a product, has to have an incredibly high level of technical knowledge. For example, let's say you're the UX designer who's designing the steering wheel for an F1 racing car. You need to understand what are all the technical capabilities that the driver needs to have at their fingertips. What are the principles on the human side, the human factors that would enable a driver to manage dozens of buttons driving 200 miles an hour, right? How on earth do they do that? They're going to have to glance down in a split second to find that button to change the brake bias or to change how the engine is tuned. And the designer going through that has to become an expert in the technical details of that platform. They're going to need to know about tire wear, brake bias. When do the drivers need to use these things? And this is, I think, another fundamental challenge, is that the designers who are helping to design these tools need over time to get that technical expertise to understand these technical users and what they're doing with the code and the data and the tools we're building.
In kind of talking about the first of those, um, the first of those directions for incorporating user experience into product, the recent Canvas uh, announcement came to mind. Can you talk a little bit about the way that user experience design went into that product?
Yeah, absolutely. So at reInvent this year, we launched Amazon SageMaker Canvas, which is a tool that enables business analysts to train machine learning models. So these are users that spend a lot of time working with tabular data sets, and they're focused on answering significant business questions with tabular data sets, maybe Excel spreadsheets. They may have data in relational databases and running SQL queries against them. And what we're hearing from customers is that uh, these business analysts often would work with data scientists or machine learning practitioners who can build models, but there's never enough data scientists and machine learning practitioners to support the business analysts. And so the vision of Canvas is basically let one of these analysts import a tabular data set and then pick a target column. We suggest what type of prediction is relevant, whether that's uh, classification or regression, and then we train a model and enable the business analyst to quickly make predictions. And it's a no-code interface. And what's exciting about it is it used the same underlying platform of SageMaker. So the models that are trained in Canvas use SageMaker Autopilot, which is our AutoML service. And so the analysts, when they train a model, can then hand it off to the data scientists who can then do additional work on that model as needed. For example, if there's multiple model candidates that Autopilot is suggested, the data scientist can come in and help the analyst at that point figure out what, for this business use case, what is the best possible model at that time. And what we're seeing is that Canvas enables these analyst users to focus on the business questions that they want to answer, and then understanding what types of things they can predict using machine learning.
And I guess it's even the name of the product kind of elicits this visual approach to building machine learning. Do you see that as extending beyond, what Canvas is today, which is, frankly, a very simple approach to solving that, relatively simple problems?
The question that I would come back to is for these analysts, what are they doing on a daily basis that where machine learning could help them, and how do we make them successful in doing that? And today, Canvas does have some data preparation capabilities, but it's not as sophisticated, for example, as the what data scientists would do in a notebook, or what they would do in a tool like SageMaker Data Wrangler, which is a low code data preparation tool we have in SageMaker Studio. And so I think we have a question in Canvas right now around, or I guess it's more of a hypothesis, that the analyst personas don't need to do heavy duty data preparation. But now that we've launched a product, we're going to get to figure out how much data preparation do they need. Do they want to do it themselves? Do they want to be assisted in doing data preparation by data scientists? At this point, our hypothesis is that they don't need to do a heavy duty data preparation. And uh, and a lot of this, this is not just sort of a wild guess, but we spent a lot of time talking to customers who have analysts who would be using a tool like this, and that's our sense right now. And so, I think part of what you're asking is where might Canvas evolve to over time. I think that's one question we have. Another question is the role of collaboration between the business analysts and data scientists. We have collaboration capabilities built into Canvas and SageMaker Studio to enable this to happen. I think our hypothesis is that these users do need to work together. Time will tell us more about the nature of that collaboration and what additional things customers need.
Yeah, I'd love to maybe spend a bit talking a little bit more about collaboration and the way you see collaboration kind of taking place in the context of the machine learning workflow in general, and notebooks in particular. I think it's easy to look at notebooks and what they, taking you from this IDE in a terminal, or a terminal that's kind of, landlocked to your computer, to a web page that, could be anywhere and offers the idea of, or the possibility of, collaboration. um, it strikes me that while that is a natural idea for notebooks, it's under implemented. Maybe I don't see it being used in that way as often as, I might expect. It's like the promise of a Google Doc, but, everyone just uses it as a regular word processor. And I'm wondering, what you observe about collaboration in the ML process in general, and the way you see that applying to, tools and notebooks in particular.
When we released the IPython notebook in 2011, users started to work with it and began to open issues on GitHub to give us feedback. And within a very short period of time, I think it was a month or two, one of the earliest feature requests we had was for real-time collaboration, similar to what you would have in something like Google Docs. And it has continued to be probably the most significant feature request we have from the Jupyter community. And and so we heard from the Jupyter user base very early on that they wanted real-time collaboration, that they looked at these notebook documents in a similar way to how they look at documents that they work with in a word processor, and wanted to collaborate with that mode of interaction. And so we've on the Jupyter side, we spent many years working on this. We've had a number of sort of false starts. It's compounded by the fact that building a the needed infrastructure and architecture for real-time collaboration from an algorithm perspective is quite complex. Thankfully, the underlying algorithms have improved over the years, and so it, just this year in Jupyter Lab 3, we've launched the first support for real-time collaboration, and we're using a another open source library that's been fantastic for this called YJS. It offers a very high performant CRDT implementation in JavaScript. And so that's really what has enabled us to build real-time collaboration in Jupyter Lab 3. And so if you any user of Jupyter Lab downloads the latest version of Jupyter Lab 3, there's a special flag you can issue at the command line that enables the collaboration feature. With that said, we're just getting started in terms of the full experience of this. There's a lot of additional user experience dimensions that we need to add, other technical dimensions, but it continues to be a major focus of the Jupyter community, and something that users want and have wanted since the very beginning. Now, the broader picture of collaboration that you mentioned in machine learning, I think what we see both at AWS and in Jupyter is that uh, there are many different personas that participate in the overall machine learning workflow, and the key points of collaboration are between those different personas. So, for example, when a data engineer who's been preparing and getting the data ready hands off a data set to a data scientist for them to work on it. And I think that that mode of collaboration between personas is really one of the main challenges we see both in Project Jupyter and in SageMaker products on the AWS side. And it's very different from environments where collaboration happens primarily among the same persona. And it adds an, that's not to say that pattern of collaboration never happens in data science and machine learning, but I think the more the more challenging one is the cross persona collaboration.
Yeah, I could see arguments for that making things easier in that you have these well-defined interfaces between, or not that they're inherently well-defined, but there's an opportunity to define an interface between the personas. Whereas if you have people in the same with the same role in the process working on the same thing, it's easier for them to kind of walk on one another's work, so to speak. But it also defining those interfaces can be challenging.
Absolutely, and that's it really is, and there's both the interface from the perspective of a programmatic API, and then also from the perspective of a like a graphical application. And the other, you quickly get into the challenges of distributed and shared data structures, and that is some personas tend to work with entities that are immutable, others with entities that are mutable, and figuring out how to get those personas to collaborate when the underlying entities that they're dealing with are fundamentally different. So, for example, software engineers are completely familiar with collaborating using Git and a version control system. But when you look at other stakeholders that want to interact with maybe the notebooks the data scientists are working with, uh, they're not going to be using Git, right? They probably want a graphical interface that allows them to comment on a notebook in the same way that you comment on a word processing document, right? They're not going to be on GitHub. They're not submitting pull requests and using the Git command line or anything like that. And yet it's still the same entity underneath. It's still a notebook at the end of the day. And so figuring out how, even what the entities and data structures are underneath the cross-role collaboration, I think is a really major challenge.
An area that I wanted to talk with you is the role of the notebook overall. This may be circling back to the very beginning of the conversation, but This is, I think, a conversation that's happening fairly broadly in our community, and that is, it often comes up as, are notebooks the right tool for machine learning, or notebooks versus IDEs. Um, and when you think about Canvas in the mix, maybe the question is, no code versus notebooks versus IDEs. Uh, how do you react to those types of questions?
Yeah, this is a great one. So first, I'll tackle the question of when should you use a notebook versus an IDE, or is the notebook a substitute for the IDE? And really, here, I think that the question to ask is, what is the fundamental activity or task you're performing? And in the case of an IDE, typically that task is that you're building something, right? You're building software, you're building a service, an API, a software product. And so the fundamental verb of an IDE, I would say, is build. Now, maybe there's secondary verbs that would be test, deploy, debug, etc., that go along with that. Whereas if you look at a notebook and what the notebook was built for and how people use it, I would say that build is probably not even secondary. And so, what is the sort of fundamental activity? I think it's really that the notebook is a tool for thinking with code and data. That when a user's working with a notebook, at the end of the day, they're trying to work in parallel with the computer to understand what is in the data and what they might predict and what the meaning of that prediction is. Is there causation there? Is there bias? How can they use this to explain the result? Do they trust the prediction that the model is making? Can they use it ethically? These are all human questions, and so the notebook really is a tool for thinking. And when you have this perspective, there's not really any confusion between an IDE and a notebook. They're two different tools that are used for two very different tasks. In the same way that an SUV and a two-seater sports car are two very different vehicles used for a different set of purposes. And if you try to take an SUV and drive it and get the sports car experience out of it, it's going to be pretty disappointing, and vice versa. And so when I hear people sort of complaining that Jupyter's not a very good IDE, sort of the filter I read that with is more along the lines of someone saying that an SUV is not a very good sports car. Namely, yeah, it's not. It wasn't designed to be. Jupyter was not designed to be an IDE in the same sense that it's used for building and deploying and debugging software products. With that said, there is a gray zone where users start to work in a notebook interactively, thinking about code and data. And at some point, a project gets to the point where it's mature enough that people start to build things. That transition is still really painful. And it's painful whether you try to keep working in Jupyter or you go from working in Jupyter with notebooks over to traditional IDE. And I think that's a major area of innovation that there's a lot of potential for the Jupyter open source community and others to dive into and figure out what does this transition look like from thinking with code and data to building software products, and how do you make that transition and work in that sort of in between zone.
Yeah, I was thinking there are a number of efforts, taking different approaches to try to productionize the notebook. And I'm sure you've seen these as well. And yeah, up until the very end of your comment, I would have thought you were thinking that those are all misguided, but it sounds like rather they're just attempts to figure out this confusing thing that we don't really know what it needs to look like just yet.
Yeah, I there's a number of efforts in the Jupyter open source community and other open source projects around taking notebooks and using them in a more production oriented way. So one idea uh, it's a Jupyter sub project called Voila. It allows users to tag cells in a notebook and then turn those cells into an interactive dashboard that looks like a web application, does not look like a notebook, and deploy that to users. So that would be more of a human oriented deployment of a notebook uh, to a group of users who never want to look at the code and the notebook, but who want to interact with the outputs of that notebook. Maybe another example, as you brought up, was the idea of scheduling notebooks, and that is that at some level you can write a notebook like you can write a Python function. A notebook could be parameterized by a set of arguments, and then you might want to run that notebook for different set of arguments on some schedule. And both of those usage cases are things that we're seeing, and I think different Jupyter users and AWS customers are doing things like that. Um, I think the more challenging cases in this space are where you want to build a machine learning model initially in a notebook, but eventually transition to building a model as part of a broader pipeline that leads to the deployment of a model with an endpoint. That transition between a notebook and the more traditional building that you do in an IDE is still quite painful. And I don't know that these notebook driven dashboards or notebook scheduling are really the right answer to tackle those.
Before we wrap up, I wanted to cover another of the announcements that was made at reInvent, and that is the new Amazon SageMaker Studio Lab product that you and your team worked on. Tell us a little bit about Studio Lab and how it came about.
Yeah. So, uh, as you mentioned, Amazon SageMaker Studio Lab was launched at reInvent this year. And the origin of this really comes back to the following question, and that is, what's the minimum set of things that someone needs to get started with machine learning? And I'm using the phrase getting started with machine learning very broadly here. This could be students who are learning about machine learning and data science in a university class. They could be learning on their own in a self paced way. Um, or it even extends to people who already have a good amount of machine learning expertise and are more enthusiasts and not doing machine learning, though, in an enterprise context where they have a support staff that maintains cloud-based infrastructure for them. And really, if you look at how people learn machine learning these days, there's a small set of things they need. One, they need notebooks. So they need some way of using Jupyter notebooks. Two, they need open source packages for machine learning. They need tools such as NumPy, Pandas, TensorFlow, scikit-learn, PyTorch, etc. And then they need some place to run the code. They need compute of some sort and storage that goes along with it. And those basic ingredients are really what is how we approach SageMaker Studio Lab. So it really is an abbreviated version of SageMaker Studio that provides a notebook-based development environment for users where they can use a Jupyter Lab-based environment, and we offer free compute and free storage along with this. And so the real significance here is that this is users don't need to have an AWS account for this. They can sign up with an email, no credit card required. There's a simple account approval step that takes a few hours. Once you have an account, you get 15 gigs of persistent storage for your project, and then you can attach that storage to either a CPU or a GPU runtime and do data science and machine learning and work with it in that context. And it's all free. And because there's persistent storage behind this, um, even though we obviously behind the scenes, we shut down the instance when you're not working, when you come back, all your files will still be there. And so this is a real file system that's persistent and allocated to your project. You can check out Git repositories locally. You can install Python packages persistently and save your data sets and notebooks alongside of all those things.
And is it from the perspective of building the product for the intended scale? Is it a Yeah, how did you think about this as a product? Was it a ground up effort, starting from, you know, components like, EC2 and all the other components that AWS has in Jupyter, or is it a starting from SageMaker and kind of trim back? How should we think about the way this came together?
Yeah, that's a great question. So when we built Amazon SageMaker Studio, that was launched at reInvent 2 years ago, we built a platform that enabled us to build these types of applications where you have an interactive user interface connected to compute underneath with a persistent file system. And so that platform was already there with SageMaker Studio, and we've reused that platform for SageMaker Studio Lab. Now, there's some key differences between the two and some common points. I'll start with the common points. So part of the reason we built this platform for SageMaker Studio was that when we talked to customers, they had security needs that could not be satisfied in a traditional Kubernetes environment. And so the platform that we're using for SageMaker Studio and for Studio Lab is we're not using Kubernetes. It's based on instances. Our customers have told us that they need instance level isolation from a security perspective. And so a lot of the work we've put in on the SageMaker Studio side with encryption at rest, encryption at transit, VPC support, instance level isolation, we've been able to take that and apply it in the SageMaker Studio Lab case. And so one of the sort of hidden features of SageMaker Studio Lab, even though it's not focused on large enterprise usage cases, it still has all the enterprise security, instance level isolation that we have on the SageMaker side of things. So we were able to reuse that. A lot of the magic of this platform is because it's instance based, there's a potential for it to take a long time to start instances. And we've done a lot of work and innovated pretty incredible stuff that enables the instant start times in SageMaker Studio Lab to be fast enough that it's not really going to get in the way of most people. Obviously, it can't be, hundreds of milliseconds or something like that, but it's fast enough. I find when I'm using SageMaker Studio Lab that the runtime and instant start time is fast enough that I don't really think about it. And so we have been able to reuse that platform for SageMaker Studio Lab. And the other point where the enterprise security is important is that we wanted SageMaker Studio Lab to be a place where we could tell users it's fine if you want to install your AWS credentials to another AWS account that you have, a paid AWS account, and make calls out from the AWS SDK or command line from SageMaker Studio Lab. And if we didn't have that enterprise security in place, we could not tell users, great, install your AWS credentials on Studio Lab.
Does that mean that there's a key store feature, or that you consider the instance level security to be robust enough that I can just, put my AWS keys in a cell in the Jupyter notebook?
So please don't put your credentials in a cell in a Jupyter notebook. That is definitely an anti-pattern, and we regularly see customers who do that and then later forget about it and version control the
Put into a
notebook, and
notebook
you
or
end up,
something?
yeah, the
Or,
credentials end up on GitHub.
yeah.
Um, so the
That's why I was asking.
no, yeah, it's a great question. Um, so the model is that your project has 15 gigs of persistent storage, and that storage is encrypted. And so you can install your AWS credentials just like you normally would on your laptop, and because the entire drive is encrypted, and we handle it with all the necessary security precautions. You can install your credentials that way. But yes, putting them directly in a notebook obviously is not recommended.
In theory, not because it's any less encrypted, but because you're more likely to put it someplace where it shouldn't be.
Yes, if you never move a notebook out of SageMaker Studio Lab, that notebook will be saved on that same encrypted volume and it will be fine. The risk is more that users would later do something with the notebook that exposed those credentials outside their original context.
Maybe just one more kind of to wrap things up. Where do you see all this going, what are you most excited about in terms of the future of ML development and human computer interfaces for machine learning?
I'll answer this personally. And for me, I thrive on ambiguity and challenge. I want to be working on things where the answer is not known, or it's not obvious, or there's significant challenges involved in coming to an answer. And I when I look at this space, the amount of challenge and ambiguity that we have left is vast. And so I find a lot of enjoyment in working in a space where there's so many unanswered questions. And some of it, this does come from my background in physics, and I love physics. And still, at the end of the day, I'm probably still a physicist. One of the challenges in physics, though, is that as the field has grown and more is known in the physics space, there are fewer and fewer unanswered questions that are available to be answered that are really deep and interesting. Now, there are some, obviously, but you really have to hunt in physics. Honestly, is my sense as a physicist is that you have to work really hard to find good problems to solve. Whereas in this space, there's an abundance of problems, and they're all really challenging and really interesting. And there's a lot of people who will benefit by solving those problems, and that's what I'm excited about in terms of looking forward in this space.
Awesome. Awesome. Well, Brian, thanks so much for joining us and sharing a bit about what you've been working on and some of the new SageMaker and Studio announcements coming out of reInvent.
Thank you so much, Sam. It's really great to be here and talk to you about all these things, and I appreciate your time and questions about the sort of the early history of Jupyter, which is a really a fun story to tell.